Now let's find the midpoints of the sides of quadrilaterals. So we need to prove that the line segment joining the midpoints of the sides of a quadrilateral are taken in the order form of a parallelogram. So here it is. Basically what this means is that this quadrilateral ABCD, right? H, this one, it says here that let ABCD be the the position vectors of the vertices ABCD. So the ends, so this is A, this is B, this is C, and this is D, right? So we let E, we need to prove, basically what the question asks, that we need to prove that the line segments joining the midpoints of the sides of the quadrilateral taken in order to form a parallelogram, right? We need to prove that when you join the midpoints of each of the sides of the quadrilateral that is given to us, it forms a parallelogram. Okay, so we just draw this out as, you can really just draw anything, but we let E be the midpoint of the line AB. We let H be the midpoint of the vector AB, so the vector AD. G is the midpoint of DC, and F is the midpoint of BC, right? So we have 4 midpoints, and it says that when you join these midpoints, it gives you this parallelogram called EHGF, or like whatever, like FGH, and like all this, right? So here's the thing. In a parallelogram, obviously, this side and this side, the opposite sides are parallel, right? So we need to prove that EH is equal to FG and GH is equal to FE. So how do we do that? Well, we use the same ratio formula. It says here that let E be the midpoint of AB. So OE is equal to the vector A, the position vector of A, plus the position vector of B over 2. How did we find this? Well, you remember that the ratio formula said that R, which is obviously the midpoint in this case, because we need to find the position vectors of, we need the position vector of E, which is OE over here. R is equal to QA plus PB over Q plus B. Now in this case, since it's the midpoint, the ratio is equal to 2:2, the ratio of Q and P. So that will basically mean that 2A plus 2B is equal to Q plus B, which is 2 plus 2, which is equal to 4. So when you take 2 common over here, that means it's 2A plus B over 4. Now you can cancel this out and this becomes 2. So that just leaves you with A plus B over 2. And that is how you got this equation over here. Now when you apply the same rule on all of the other side, you find out that OF, which is the position vector of this F over here, that is equal to B plus C over 2, because it's between B and C, right? And for G, you guessed it, it's C plus D over 2. And for H, it's A plus D over 2. Okay, now that you have this information, you know that FE is equal to OE minus OF. Obviously, because, well, that's just how it is. If you draw out the whole thing, you can use the head to tail method to see that FE is equal to OE minus OF. Now, let's just see. FE, right? FE, and when you take this to the origin side, let's say that this is the origin. Oops. If you say that this is the origin, that means that this is OE and this is OF, and this is OE, this is OF, and that means that OF plus FE is equal to OE. So OF plus FE is equal to OE, which means that FE is equal to OE minus OF. And that's how you prove that, right? And similarly, you can use the same head to tail method for all of the other sides. So you see that FE and GH give you the same result, AA minus C over 2, which means that both those two sides are parallel. And similarly for FG and EH, when you do all the calculations, you find out that they are parallel as well, which means that two sides are parallel, the two opposing sides, which means that this is indeed a parallelogram, right? Because when the two opposing sides are parallel in a four-sided quadrilateral, that means that it is a parallelogram.